Let's start with analytical geometry. In this part of the lesson, we are going to look at these 8 concepts, some of which you have already covered in grade 10. We are going to look at the distance between 2 points, the gradient between 2 points, the midpoint of a straight line, or a midpoint between 2 points as well, the collinear points, or points that lie on the same straight line. We will look at the properties of parallel and perpendicular lines. We will also look at the properties of some of the important quadrilaterals that you need to know in order to solve most of the problems in analytical geometry. We will then look at the equation of a straight line, and then finally we will look at the angle of inclination of a straight line. Let us start right away with the distance between 2 points. These concepts have already been covered in grade 10, so what I am going to do is to demonstrate how to find the length or the distance between 2 points with examples. In this example that we are given, we are required to calculate the length of AC, BC, and AB. Here is AC, BC, and then the length of AB. By looking at the sketch, we see that the line BC is parallel to the y-axis shown by this arrow, and the line AC is parallel to the x-axis shown by this arrow. Now, to calculate the distance between 2 points, if you know that the 2 points are parallel to the x-axis or parallel to the y-axis, there is no need to use the distance formula that we used in grade 10. In this case, you can only focus on the x values or the y values depending on how your points are positioned. So for the straight line AC, we see that AC is parallel to the x-axis. In this case, it means that the y values for the 2 points, the point A and the point C, will be the same. If you look at the y coordinate of point A, it's -3, and the y coordinate of the point C is also -3. So if we subtract this point from that, we will get 0. In other words, the y value or the y coordinate of these 2 points doesn't contribute to the length of AC. It will always be 0, and 0 doesn't really contribute to anything. So to find the length between the points A and C, we only focus on the x coordinates of these 2 points. We could start from the origin and see how long it takes us to get to C. So you can see that if we start from the y-axis, it will take us 2 units to get to C. And again, if we start from the origin at the y-axis to A, it will only take us 4 units to get to A, ignoring the signs. So it takes 4 plus 2, which means the length of AC will be 6 units. Now, the quickest way to do this is to subtract the smaller value from the bigger value to get the answer. So in this case, we have 2, which is bigger than -4. So to find the length of AC, we could simply say 2 minus into -4, which will be 2 plus 4, and then that gives us 6 units. In the same manner, to find the length of BC, which is parallel to the y-axis, we are going to focus on the values of y, simply because the value of x doesn't change. We have 2 at B, and then we have 2 at C. 2 minus 2 will be 0, and 0 will not contribute to the length of BC. So we are only going to concentrate on the values of the y coordinate. So subtract the smaller value from the bigger value. We have 5 minus into -3, which is 5 plus 3. That gives 8 units. We could also have done it like we did with AC, and say from the origin, the x-axis, we move 5 units to B, and then from there we move 3 units to C. 3 plus 5 would give us 8 units. Now to find the length of AB, which is not parallel to the x-axis and it's also not parallel to the y-axis, we need to use the distance formula, which was covered in grade 10. Remember the distance formula? This is the square root of the difference of the x values all squared plus the difference of the y values all squared. Now what is important to remember with the formula is that if you start with the x value at B, you must also start with the y value at B for consistency and also to get the correct answer. So in this problem, we started with the x value at B, and then we subtract the x value at A, and then we square the difference. We do the same with y, we square the difference to find the length. So once you have this, the only thing that you have to do is to substitute the right values. The x at B is 2, the x at A, it's minus 4, the y at B is 5, the y at A is minus 3. So if we do the substitution, we end up with the square root of 100, which is 10 units. That means the length of the straight line AB is 10 units. Let's move on to the gradient. Like we did with the distance, we are going to use an example to demonstrate how to find the gradient between 2 points. This requires us to calculate the gradient of AC, BC, and AB. So this is our AC, that's our BC, and this is our AB. Like in the previous problem, BC is parallel to the y-axis, AC is parallel to the x-axis. Now to find the gradient of AC, there is no need, in fact, to also calculate the gradient of AC, since AC is parallel to the x-axis. So if a line is parallel to the x-axis, it will always have a gradient of 0. The reason being, the gradient between 2 points is the change in the value of y over the change in the value of x. So in this case, the value of y from C to A doesn't change. So it's minus 3 and it's minus 3. So if we say minus 3 minus into minus 3, that would be minus 3 plus 3, which will be 0. So the change in the y value is 0, and the change in the value of x, of course, is there. So therefore the answer will always be 0. If a straight line is parallel to the x-axis, it will always have a gradient of 0. We can show that with calculations. This will always be true. If a straight line is parallel to the x-axis, its gradient will always be 0, because the change in the value of y is always 0. And if for the gradient of the straight line BC, since BC is parallel to the y-axis, its gradient is undefined. A straight line that is parallel to the x-axis, it will not have a gradient, so its gradient will be undefined. But we can show that with calculations. Remember, a gradient is a change in the value of y over the change in the value of x. So if we do the substitution here, you will notice that the denominator becomes 0, and division by 0 is undefined. Therefore, the gradient of a straight line that is parallel to the y-axis will always be undefined. So if you have a vertical line and you can show that it is parallel to the y-axis, its gradient will always be undefined. Now to find the gradient of the straight line BC, we use the same equation. That will be the change in the value of y between a and b over the change in the value of x between a and b. So what is important again is to remember that y will always be the numerator and x will be the denominator. And if you start with the y at b and subtract the y at a, you must do the same with the x value. You must take the x value at b and subtract the x value at a. You don't need to start with the y value at b. You could as well start with the y value at a and then you subtract the y value at b. But what you do with the values of y, you must also do the same with the values of x. So in this case, we choose y at b and then we subtract y at a. X at b, we subtract the x at a. All we have to do is to substitute the correct values, and then this leads us to minus 4 over 3. So the gradient of the straight line AB is minus 4 over 3. And this is something that you must always be able to see whenever you are calculating the gradient of a straight line. So a straight line that is falling in this nature will always have a negative gradient. And a straight line that is rising in this direction will always have a positive gradient. So it doesn't matter where it is. It could be here, but rising, rising, rising. That straight line will give a positive gradient. And any straight line that is falling in this nature will always give you a negative gradient. Let's now look at the midpoint between 2 points. In this problem, we are required to determine the coordinates of M, N, and P if these points are midpoints of AB, BC, and AC respectively. So here it's shown M is the midpoint of AB, N is the midpoint of BC, and P is the midpoint of AC. Remember the midpoint formula that was covered in grade 10. So to find the midpoint between 2 points, so to find the midpoint between 2 points, all you have to do is to find the average of the x values to find your x coordinate. So that means you would have your x at b plus the x at a divided by 2 because they are just 2 x values. And then to find your y coordinate value, it would be y at b plus y at a divided by 2 because there are only 2 y values there. So that would give you the midpoint between any 2 points that you are given. So the midpoint between the midpoint between AB, or the coordinates of M, will be given by the x at A plus the x at B divided by 2, the y at A plus the y at B divided by 2. So when you're calculating the midpoint, the order of how you write this doesn't really matter. I could have started with the x at B plus x at A, and then here start with y at A plus y at B. It wouldn't affect the answer that I get. So now once you have that, the only thing that you have to do is substitute the values, which gives us minus 1 and 1. So finding the midpoint of 2 points, you simply find the average of the x coordinates to get the x value of that midpoint, and then you also find the average of the y values to find the y value of that coordinate. So in this case, the average that we got is minus 1 and 1, which are the coordinates of the point M. We'll do the same with BC and the same with AC to find 2 and 1, and then also to find minus 1 and minus 3. So this is how you would find the midpoint between 2 points, or the midpoint of a straight line. And then now let's move on to collinear points. Now when we say points are collinear, we mean that they lie on the same straight line. So in this example, we are told that A, B, and C are collinear points, and they want us to calculate the value of A. What is important about collinear points? Because they lie on the same straight line, if you pick any 2 points there, they will always give you the same gradient. So in other words, if I try to calculate the gradient of AB and compare it with the gradient of AC, I'll always get the same value. If I calculate the gradient of BC, compare it with the gradient of AB, it will always give me the same gradient. So whichever 2 points that you pick, if you are told that those points are collinear, whichever 2 points you pick, they will always give you the same gradient. So that is how you solve most of these problems, by using the property that they have the same gradient. Regardless of which points you pick, you will always get the same gradient. So in this case, we know that the gradient of AB should be the same as the gradient of BC. I picked BC because I can be able to calculate a numeric value for this. It doesn't involve the variable A, so that's why I picked this. You could as well have chosen AB and AC, you still get the same value. So it doesn't matter which 2 points you choose, you would still get the same value because they are collinear points, and any 2 points that you pick will give you the same gradient. So in this case, I calculate the gradient of AB and the gradient of BC and try to simplify, equate the two, and I get my value of A to be 3. So the value of A is 3 in this case, by using the property that the property of collinear points, that they have an equal gradient. Let's then look at parallel and perpendicular lines. Let's look at the properties of parallel and perpendicular lines. What you need to know about parallel lines is that they have the same gradient. So if you are told in a problem that 2 lines are parallel to each other, what you must know right away is that the 2 lines have the same gradient. And what you need to know about perpendicular lines, if 2 lines are perpendicular to each other, or they make an angle of 90 degrees at the point of contact, then you must know that the product of their gradients will always give you -1. So in this case, I have a straight line EC and a straight line BD. If I multiply the gradient of the straight line EC with the gradient of the straight line BC, the answer will always be -1, because the 2 lines, or the 2 straight lines, are perpendicular to each other. And for the straight line AE and the straight line BD, their gradient will always be the same because they are parallel to each other. Parallel lines have the same gradient. Perpendicular lines, when you multiply their gradients together, you get a -1. So let's have a look at this problem. We are given this information. Now they want us to calculate the gradient of the straight line AE, and the straight line EC. From the sketch, we can see that the straight line AE is parallel to the straight line BD. This is shown by these 2 arrows, and of course the information is also given up there. And then we also know that EC is perpendicular to BD, so EC is perpendicular to BD. This is the EC we want, and then this is the AE that we also want. What will be the gradient of AE? To find the gradient of AE, we realize there's nothing we can do on the straight line AE. We do not have the coordinates for A, we do not have the coordinates for E, but what we have are the coordinates for B and the coordinates for D. And these 2 straight lines are parallel to each other. So to find the gradient of AE, we can calculate the gradient of BD, and then that will give us the answer for the gradient of AE, because the two lines are parallel to each other. So what we do, we calculate the gradient of the straight line BD, and we get 4. So the gradient of the straight line BD is 4. What then will be the gradient of the straight line AE? The gradient of the straight line AE will also be 4, because the two lines are parallel to each other, because AE is parallel to BD. This information is given to us, and we can also see it from the arrows that are given here. Now to find the gradient of the straight line EC, we look at the straight line EC. We do not have any points. E doesn't have points, or it doesn't really have the coordinate values, and C also doesn't have the coordinate values. So there's nothing that we can do by working with point C and E only. But we realize that, or we're given that EC is perpendicular to BD, and we know that the gradient of the product of the gradients of perpendicular lines is always -1. So this is where we start. We know that the gradient of the straight line BD multiplied by the gradient of the straight line EC must give us -1, because the two lines are perpendicular to each other. We already have the gradient for BD, it's 4. If we substitute, this will give us the gradient for EC. So the gradient for EC, we divide both sides by 4. That will be -1/4. So the gradient of the straight line EC is -1/4. Remember, -1/4. Remember this. Parallel lines have the same gradient. The product of the gradients of perpendicular lines is -1. Let us now look at some quadrilaterals that you will need to solve most of your problems in analytical geometry. Okay, let's start right away with the parallelogram. So a parallelogram, it's any four-sided figure, because quadrilaterals are actually four-sided shapes. So your parallelogram is any four-sided figure whose opposite sides are equal and parallel to each other. So in this case, this side and this side are equal and they are parallel to each other. This side and that side are equal to each other and they're also parallel to each other. So the second property of a parallelogram is that the opposite angles are equal in size. So the opposite angles of a parallelogram are equal in size. So in other words, this angle here will be equal to that angle over there. So if this is 50 degrees, that will also be 50 degrees. And if this is 130 degrees, that will also be 130 degrees. So the opposite angles of a parallelogram are equal in size. And the third property is that the diagonals bisect each other. We have this diagonal, we have that diagonal. So at the point where they meet, that is the midpoint of this diagonal, and it is also the midpoint of that diagonal. So that's the important part. They bisect each other, which means they cut each other into equal halves. So at the point that they meet, so at this point where they meet, this is the midpoint of this diagonal, and it is also the midpoint of the other diagonal. So that information will help you to solve most of the problems once you are told that you are working with a parallelogram. Let's look at the second one, which is a rectangle. Now, a rectangle, like the parallelogram, the opposite sides are equal in size and they are also parallel to each other. So this side is equal to that side, this side is equal to that side, this side is parallel to this side, this side is parallel to that side. So the opposite sides are equal and parallel. So they are equal in length and they are parallel also. And the second property is that the diagonals bisect each other. So the diagonals, this diagonal over there and that diagonal over there, bisect each other. That means at this point where they meet, that is the midpoint of this diagonal, and it is the midpoint of that diagonal. And another important part is that the diagonals are equal in length. So the diagonals of a rectangle are equal in length. In other words, if this diagonal is 10 centimeters, this will also be 10 centimeters. And that makes it that makes an interesting part, because if the diagonals are equal in length and they bisect each other, that means all these will be equal in size. So if this is the midpoint and this diagonal is 10 centimeters, that means this will be 5, 5, 5, 5. So they will all be equal in length because the diagonals are equal in length and they also bisect each other. Let's now look at the rhombus. The rhombus, the first property, just like the other two, the opposite sides are equal and they're also parallel. So the sides are equal in length and they are parallel to each other. So this side is equal to this side and the two are also parallel to each other. That side is equal to this and they are also parallel to each other. That is the first property, which is shared by the parallelogram, shared by the rectangle, and it is also shared by the rhombus. Now, the second property is that the diagonals bisect each other. But at the point where they bisect, they make an angle of 90 degrees. So that means the diagonals do bisect each other, just like with the parallelogram and the rectangle. But there is something special. At the point where they bisect each other, they make an angle of 90 degrees. So they bisect at an angle of 90 degrees. So it is also shown at this point here. It's 90 degrees. And then finally, we know that the diagonals of the rhombus bisect the opposite angles. So this diagonal here, it bisects this angle. So if originally this angle was 50, we draw this diagonal here, this will be 25 degrees and that will be 25 degrees. Similarly, it bisects this angle. So if this angle was 50 degrees, it would be 25, 25. So the diagonals of a rhombus bisect the opposite angles. Similarly, this rhombus here, this diagonal here will bisect this angle. If this angle was 130 degrees, then you would have 65 degrees, 65 degrees, 65 degrees, 65 degrees. So the diagonals of a rhombus bisect the opposite angles. So the opposite angles are bisected. This is very important to remember when you are solving a problem. Let's look at a square now. A square is more or less the same as a rhombus, and just like the other three that we've spoken about, the parallelogram, the rectangle, the rhombus, the opposite sides are equal in length and they are parallel to each other. So the opposite sides are equal and parallel to each other. The diagonals bisect at 90 degrees, just like the rhombus. The diagonals are equal in length, just like the rectangle. So if this is 10 centimeters, that would also be 10 centimeters, and they bisect each other at 90 degrees, making all these to be equal in length. And the diagonals also bisect the opposite angles, just like the rhombus. So these angles will all be 45 because all the angles of a square are 90 degrees each. So this is 90 degrees, that is 90, that is 90, that is 90. So that means this diagonal, it bisects this 90 into 45 degrees and 45 degrees, 45 degrees and 45 degrees. So that's what the diagonal does. So, and also the other part that we know about a square is that all its sides are equal in length. we know that if this is 5, that would be 5, that would be 5, that would be 5. That is what we know about a square. So now let's look at a kite. So a kite, what is noticeable here is that the diagonals bisect each other, and the longer diagonal bisect the shorter diagonal at an angle of 90 degrees. So this shorter diagonal doesn't bisect this one, right? So this is not equal to that. But the shorter one, the longer diagonal bisects the shorter diagonal at an angle of 90 degrees. So this would be equal to that. And most of the properties can be seen from the structure. The opposite, this diagonal, the longer diagonal bisects the opposite angles, and that's what you need to know about a kite. And finally, we have a rhombus, and the only property of a rhombus is that the two pair or one pair of opposite sides are parallel to each other. So you have this side being parallel to the other side. So there's only one pair of opposite sides that are parallel to each other. I want us now to look at how to find the equation of a straight line. So there are three scenarios in which you may be required to calculate the equation of a straight line. In the first one, you may be given 2 points. So if you are given 2 points and you have to find the equation of a straight line, you can use this 2-point form approach to calculate the equation of the straight line. So you've been given 2 points and you are required to calculate to find the equation, or to determine the equation of that particular straight line. You could use y minus y1. Of course, y1 being the first point that you pick, there may not be a need for you to use 1 here if the point is A and the other point is B. So instead of saying y1 and y2, you could say y at A, y at B. So in this case, let's stick with the y1 and y2. So you say y minus y1, x over x minus x1 equals to the equation of a gradient. So the equation of a gradient is y2 minus y1 divided by x2 minus x1. So what is important here is to see that you have y minus y1 divided by x minus x1 equals to the equation of a gradient. So this is when you are given 2 points and you are required to determine the equation of a straight line from those 2 points. So in some instances, you may be given a point and a gradient. And this is very much common. So when you are given a point, just 1 point on a straight line, and there is a way for you to calculate the gradient, or the gradient is given to you as a value, then you can use this gradient point form to determine the equation of that straight line. So this is given by y minus y1 equals to m into x minus x1. That's when you are given the value of the gradient and a single point on that straight line that you are required to determine the equation of the straight line. So the last one is actually the general form of how we write the equation of a straight line. So at the end of the day, when you have simplified these two, your answer must look like this. But also, it is the third part or third version of finding the straight line, the equation of a straight line. And it works when you have been given the y-intercept and a gradient. So in this case, if you've been given the gradient and the y-intercept, you can use this approach to find the equation. Let's say maybe you are given that the gradient is 2 and the y-intercept is 1. So there's no need to struggle, because you already have the 2 values that are required, where your c will be the y-intercept and the m will be the gradient. So in this case as well, your m is the value of the gradient. So if you are given the gradient and the y-intercept, so this is the y point where your graph, this is where your graph touches the y-axis. So the value at that particular point, if it's given to you, and you also have the gradient, so you can use this approach to find the equation of a straight line. Now, let's get to this example where we are required to determine the equation of the line BC, the line AD, and AF in the form y equals to mx plus c. Here is our BC, and here is our AD, and then here is our AF. Let's look at BC. The straight line BC, we have the point B with all its coordinates. We have the point C with all its coordinates. So in BC, we've been given 2 points. If you are given 2 points, we said you can use this approach, the 2-point method, to find the equation of a straight line. So in this case, if we use the 2-point method, all we have to do is to substitute the right values. I've chosen B and C, so I start with the values at B and then also substitute the values of C. Like I said before, the 1s and the 2, they just tell you which points you decide to put as 1 and which point you decide to put as 2. So in this case, my 1 here is the point B, and my 2 here is the point C. So I have that, and then I substituted the right values. So the y value at B, which is 5, the x value at B, which is 1. So I'll have y minus 5, x minus 1. And then I'll do the same, the y at C minus the y at B, and the x at C minus the x at A. Then all I have to do is to simplify this to arrive at y equals to minus x plus 6. Therefore, the equation of the straight line BC, which is given by the 2 points, is given by y equals to minus x plus c. In other words, the value of the gradient m is minus 1. The value of the y-intercept c is positive 6. So the equation of the straight line BC is minus x plus c. Now let's find the equation of the straight line AD. So on the straight line AD, if you look at it, we only have the point A with coordinates, which is minus 2 is to minus 3 over 2. And we have nothing else on that straight line except the information that AD is parallel to BC, which is shown by these arrows. So these 2 arrows tell us that AD is parallel to BC. And we know that parallel lines have the same gradient. So if you are given 2 parallel lines, you know that they will have the same gradient because parallel lines have the same gradient. We know the gradient of BC because from this equation, we have the value of m, which is minus 1. Therefore, the gradient of the straight line BC is minus 1, meaning that the gradient of the straight line AD will also be minus 1. So we can use this second approach of finding the straight line, the gradient point method, because we have the gradient, which is minus 1, and we have 1 point A. So we can use this approach to determine the equation of the straight line. All we have to do is to substitute the right values. It's y minus into minus 3 over 2 because this is negative, the minus 1 for the gradient coming from this equation, into x minus into minus 2 as well. Remember the equation says x minus, and this is also negative, so it will be minus 2 as well. So all we have to do is simplify to arrive at y equals to minus x minus 7 over 2. So the gradient value for the straight line AD is minus 1, which equals to the same gradient for the straight line BC because the 2 lines are parallel to each other. And the y-intercept, or the value of c, is minus 7 over 2. And now we have to find or determine the equation of the straight line AF, the straight line AF. On the straight line AF, just like the straight line AD, we only have the coordinates of the point A, we do not have the coordinates of the point F, so we only have one point with coordinates. But we also have an extra information. We are given that BC is parallel to AF, shown by this 90 degrees angle over there. So we know that the two lines are perpendicular to each other. So the two lines are perpendicular to each other. And we know that the product of the gradients of two perpendicular lines equals to -1. In other words, to find the gradient of the straight line AF, we can multiply its gradient with the gradient of the straight line BC, and that will give us the gradient of the straight line AF, which is 1. We know that the gradient of BC multiplied by the gradient of AF must be equals to -1 because the two lines are perpendicular to each other. Now that information has helped us to find the gradient of the straight line AF. So in this case, we have the gradient of the straight line AF, and we also have a point with coordinates. We can use the point gradient method to find the equation of the straight line AF. So all we have to do now is substitute and arrive at the solution, which is y equals to x plus 1/2. So the equation of the straight line AF is given by x plus 1/2. And the last part of the lesson before we try a few examples is the angle of inclination, or the inclination of a straight line. So the inclination of a straight line is an angle that is made by the positive x-axis, or the positive direction of the x-axis, with the straight line of interest that we are working with. So we look at the x-axis and then we move in the positive direction. Remember, when we measure angles are positive when we measure them in an anti-clockwise direction. So if we start here on the x-axis and we move in an anti-clockwise direction, that would be the positive direction of the x-axis that we are referring to here. So now, to find the inclination of the straight line AB, start on the x-axis, we move all to the straight line AC. So the angle theta will be the inclination of the straight line AB, and the angle beta will be the inclination of the straight line AC. So these are the angle of inclinations of these two. So now, to find the angle of inclination, let's start with the angle of inclination of the straight line AC. So we are finding the angle beta. How do we find the angle beta? There is the relationship between the tangent of this angle and the gradient of the straight line. And this is the most important part that will help you to find the angle theta. So there is a relationship between the tangent of the angle beta and the gradient of the straight line AC. In the same manner, there is the relationship between the tangent of the angle theta and the gradient of the straight line AB. But let's start with the straight line AC. So what we know is that the tangent of the angle beta will be equals to the gradient of the straight line AC. So that relationship is important. This is the approach that you will use to calculate the value of the angle beta. Now we know how to calculate the gradient of AC. That we can do because on the straight line AC, we have been given the coordinates of the point A, we have been given the coordinates of the point C. So we can use that knowledge to calculate the gradient of the straight line AC. And that gives us 7/5. So the gradient of the straight line AC is 7/5. the relationship between the angle beta and the gradient of the straight line AC. We know that the tangent of the angle beta will be equals to the gradient of the straight line AC. So tan beta equals to 7/5. So in this case, we can use our knowledge of trigonometry to find the angle beta. So that will be, beta will be given by the arctan of 7/5. And that gives us the value of 54.46 degrees. So to find beta alone, we use the arctan of the value that we're given here, and then we find the gradient. Okay, we find the value or the size of the angle beta. So the angle beta, which is the angle of inclination of the straight line AC, is 54.46 degrees. So that is the inclination of the line AC. So this is what we are calculating. Now let's find the inclination of the line AB. In the same manner, the relationship between the angle theta and the straight line AB is that the tangent of that angle theta will be equals to the gradient of the straight line AB. All we have to do is to find the gradient of AB. In this case, it's -9/2, and we equate the two. We use our knowledge of trigonometry to find the arctan of -9/2, and the answer that we get is -77.47. Now, this is what you need to take note of. Whenever you are calculating the inclination of a line or the angle of inclination, your answer must always be positive. Your answer must always be a positive value. So if you get a negative value, you need to add 180 degrees so that that value of yours becomes a positive value. So it's easier to understand this concept. If you are getting a negative value, that means you are getting a value in the fourth quadrant. So that value is in the fourth quadrant. So this is an angle measured in a clockwise direction. So that would be an angle in the fourth quadrant. So if you have a -77 degrees point, okay, -77.47 degrees in this angle, you can make it a positive value by adding 180 degrees. So if you have it here, so if you add 180 degrees, this angle will take you in the second quadrant. So it will take you in the second quadrant. It will be an obtuse value, which is more than 90 degrees, but it will still be the same as -77.47. So what you have to do is to add 180 degrees to your answer so that you get an obtuse angle, which is 102.53 degrees. So remember that the angle of inclination will always be a positive value. If you don't get a positive value, add 180 degrees to your answer so that the answer is a positive value. Let's look at some exam type of problems. These are problems that you are more likely to meet in an exam. So in this problem, we are told that M is the midpoint of the straight line EC. So M is the midpoint there. And also by looking at this diagram, we can see that AE, the line AE, is parallel to the line BC, which is shown by these two arrows here. And then also that the line AD is perpendicular to the line BC, shown by these 90 degrees over there. So that information is important. We're able to see it there, and it tells us more about what we might need to use when we solve most of the problems in this question. Now the first question says, calculate the gradient of the straight line BC. We have the straight line BC, and BC, we've been given all the coordinate values of B, the coordinate values of C. So to calculate the gradient of BC, we know it's just going to be the change in y over the change in x, and that will give us the value of the gradient. So the gradient in this case is 1 over 2. That is the change in the value of y over the change in the value of x, and that is 1 over 2. The second question says, determine the value of x and y. The value of x is part of the midpoint here, and the value of y is part of the coordinates of E. Now we've been told that this is the midpoint of these two, and now we are required to calculate the value of x and the value of y. We know how we find the values of, or the coordinate values of the midpoint. We can use that understanding in a reverse order to calculate the value of x. We know that to find the value of x of the midpoint, we simply find the average of these two. So if we take the x at E plus the x at C, and then we divide them by 2, they should give us this value here. So we know that if the x value of the midpoint, or the coordinates of M, is given by the average of the x value at E and the x value at C. And we already have these two. If we substitute, we find that the x value is 5. So we used our understanding of how to calculate the midpoint of 2 points now to find the value of x, and that's the direct way of finding the value, the x value of the midpoint. And in the same way, we can reverse how we found the value of 2, or the value of y here, the y value of the midpoint M. We can reverse that understanding to find the value of y. So we can reverse how we calculated these two in order to find the value of y. We know that 2 is given by the average of the y values at E and C, and now we can simply substitute. We know that the y value at E is y, and the y value at C is -2. If we simplify this, we get y equals to 6. So 2 times 2 gives you 4, and then you take -2 to the other side, it will be positive, so it will be 4 plus 2, which will be 6. So the x value is 5 and the y value is 6. The third question says, calculate the length of BC. So this is the distance problem. So we are required to calculate the length of the straight line BC. We know how to find the length of this. We are going to use the formula in this case because we do not know, or by just looking at it, obviously BC is not parallel to the x-axis, so we can use that understanding of subtracting the x values, and it is obviously not parallel to the x-axis, so we need to use the distance formula. Remember, the distance formula is the difference in the x values between B and C, and then you square it, and the difference between the y values between B and C, and then you square the difference. So we started with the x at C. We need to start with the y at C for consistency and also to get the correct answer. So all we are left with here is to substitute the right values, and then after substitution we get the square root of 80 as the answer. So the distance between B and C, or the distance between the points B and C, is the square root of 80 units. And the fourth question says, if we are told that the length of AE is also the square root of 80 units, to which group of quadrilaterals will ABC belong to? So you look at this quadrilateral. This side is given that it is parallel to there, and we are also given that, okay, we have calculated this value, the value of BC, or the length of BC, to be the square root of 80, and then we also know that that side also is the square root of 80 from this information. So the opposite sides are equal in length, and they are parallel to each other. By just looking at this shape, it can be a rectangle. You can tell that this can only qualify to be a parallelogram with the opposite sides parallel to each other and also equal in length. So this could be a parallelogram. The fifth question wants us to determine the equation of the straight line AD in the form y equals to mx plus c. So if you look at the straight line AD, we only have one point, a point with coordinates. D is a point, but it doesn't have coordinates. But we have been given some information here. By looking at it, we know that AD is perpendicular to BC because of this 90 degrees here. And we know something about perpendicular lines, that the product of their gradients equals to -1. In other words, the product of the gradient of the straight line AD multiplied by the product, the product of the gradient AD, the gradient of the straight line AD and the gradient of the straight line BC will give us -1. We already have the gradient of the straight line BC, which we calculated there to be 1/2. So if we substitute, we can find the gradient of the straight line AD, and that is -2. So we have found the equation, the gradient of the straight line AD, and it is -2. Now we have a gradient, and then we also the point A. In this case, we can use the gradient point method to find the equation of the straight line AD. The gradient point method, all we have to do is to substitute the right values. Our m is -2, we calculated it here. Our y2 it's +2, so it will be -2, and our x1 it's -2, so x minus into -2, that would just be x plus 2. If you simplify that, you get y equals to -2x minus 2. So therefore the equation of the straight line AD will be given by -2x minus 2. And finally, we are required to calculate the coordinates of the point D. At the point D, that is an intersection of two straight lines. Remember, we have found the equation of the straight line AD, and we know that we can find the equation of the straight line BC, and that will be worth it. Just look at the marks. So the marks, we have 5 marks to work on this problem, and you realize that finding the equation of BC will be part of this problem. We already have the equation of AD. It's y equals to -2x minus 2. So now all we have to do is to find the equation of the straight line BC. And why are we doing that? It's because at D we see that the two lines intersect. So if we can find the equation of the straight line AD and then also the straight line of the equation BC and equate them at the point D, we should be able to find the coordinates of D. Now, our target is to find the equation of the straight line BC, and then this is what we are doing. We know that we have the gradient of the straight line BC is 1/2, so we use the gradient point method. We have the gradient, and then we use any of these points. So I'm using this point here, the point C, and then we do the substitution, and the equation becomes y equals to 1/2x minus 4. So this is the equation of the straight line BC. Now we know that at this point D, the two equations intersect, or they meet, and when the two of them intersect, that means they are equal at that particular point. Now, in other words, the equation of the straight line BC will be equals to the equation of the straight line AD at D. All that is left for us to do is to simplify this, giving us the x value to be 4/5. So the x value at D is 4 over 5. Now all we have to do, since we have the x value, all we have to do is to take this x value, substitute it in the equation of BC or in the equation of AD. In either case, we should be able to find the same value of y. So if we substitute it, we get the value of y to be minus 18 over 5, meaning that the coordinates of D are given by 4 over 5 and is to minus 18 over 5. So those are the coordinates of D. Let us look at another problem. In this problem, we are told that ABCD is a rectangle. So ABCD is given to us as a rectangle. And the first question wants us to determine the gradient of CD. So we have to find the gradient of this straight line. And before we get to that, let's quickly recap on the properties of a rectangle. We did speak about this. The properties of a rectangle, we know that the opposite sides are equal in length and they are parallel to each other. So AB will be equals to CD and they are also parallel to each other. AD will be equals to BC and they are also parallel to each other. So that's the most important part that you need to know. And we know that the diagonals bisect each other and the diagonals are equal in length. So that is also very important. The angles, all of these angles are 90 degrees. So you need to remember, whenever they say rectangle, remember those quadrilaterals that we spoke about, and then remember all those properties so that we can be able to solve most of these problems. Now, the first one, they want us to calculate the gradient of the straight line CD. And here we have all the information we need. We have the coordinate values for C, we have the coordinate values for D. So all we have to do is to find the change in Y over the change in X and find the gradient, so which will be 3 over 2. So the gradient of the straight line CD is 3 over 2. Now they want us to calculate the size of the angle theta. The angle alpha. So they want us to calculate the value of, or the size of the angle alpha. We know that alpha is the inclination of the straight line CD. So this is the angle of inclination of the straight line CD. How do you find the angle of inclination? We know the relationship between the angle of inclination and the gradient of the straight line. We know that the tangent of the angle of inclination will be equals to the gradient of the straight line CD. We have already calculated the gradient of the straight line CD, which is 3 over 2. All we have to do now is to use our trig to find the value of alpha. And in this case, alpha is given by 56.31 degrees. So that is the angle of inclination. 2.3, they want us to determine the value of y. Let's look at y. Y is the y coordinate of the point A. They want us to determine the value of y. There are many approaches you could use to arrive at the solution for finding y. But in this case, I want to use the understanding of gradients to find that value. I know that the line AD is perpendicular to the line CD because this angle is 90 degrees. This is a rectangle, by the way. So the gradient of AD multiplied by the gradient of CD should give me a -1. So by using that approach, I can be able to find the value of y. So in this case, the gradient of AD will be given by y minus 6 over minus 3, simply because we don't have the value for y. And then we have the gradient of CD, which is 3 over 2. So if I multiply the two, I should be able to get -1. Simplify that, I get y equals to 8. Therefore, the value of y is 8 by using the understanding of the product of their gradients, because the two straight lines are perpendicular to each other. And how do I know that? Okay, I'm given a 90 degrees here. Even if I wasn't given a 90 degrees angle, I would know that this is a rectangle, and the angles of a rectangle are all 90 degrees. Therefore, AD will be perpendicular to CD. I use that understanding to arrive at the value of y, which is equals to 8. 2.3. Okay, now we get to 2.4. Now we are required to calculate the size of the angle theta. So what we are required to find here is the value of the angle theta. The approach that I want to use here is to use my understanding that this line AB is parallel to the line CD. Remember, this is a rectangle. The lines, the opposite sides are equal in length, and they're also parallel to each other. So that knowledge, you needed to have it in order to be able to use it. Now, knowing that AB is parallel to CD, I will know then that this angle here will be theta. This will be alternating angles. That line being parallel to this, so you can have this Z over here. So this angle will be equals to that. So this angle over here will be theta. So knowing that this angle here will be theta, my approach is simple. I can find the gradient of this line and then find the inclination of the whole line. Remember, I already have the value for alpha. The value for alpha is 56.31. So now I'm going to find the inclination of the whole straight line AC. So I'm going to find the inclination of AC. So it's going to start from here to AC. Now, the tan of angle ACX, I'm talking about the whole angle there, will be equals to the gradient of the straight line AC. So all I have to do now is to find the gradient of AC, and the gradient of AC is 8. The gradient of the straight line AC is just 8. So to find the angle ACX, the whole of this, I know that that's going to be the tan of ACX is given by the gradient of the straight line AC. So you do the substitution, use trig, we get the value as 82.87 degrees. That is the value for the whole of this angle, starting from the x-axis all the way there. But to find this value here, that means I need to subtract, to remove this alpha from the answer. But I already have the alpha there, right? So if I say 82.87 degrees minus alpha, I should be able to find only this value here. And I know that this value equals to that value because this line is parallel to that. So this will be alternating angles. And therefore ACD, what I'm looking for, the angle ACD, this angle here, will be 82.87 degrees minus 56.31 degrees, which is 26.56. Therefore, the angle theta will be 26.56 degrees because it is equals to the angle ACD. They are alternating angles because AD is parallel to, AB is parallel to CD. It can be AD parallel to CD. AB, this should be B, is parallel to CD. Let's move on to problem number 3. In this problem, we are given that AD is parallel to BC. This is shown by these arrows here. And the first question wants us to calculate the gradient of the straight line BC. So we have the straight line BC, we have the coordinate values for B, we have the coordinate values for C. All we have to do is change in y over the change in x, and then we have the gradient as 4 over 3. So the gradient of the straight line BC is 4 over 3. And the second question, 3.2, they want us to determine the equation of the straight line AD. How do we find the equation of the straight line AD? We only have one coordinate values, which are the coordinates of A on the straight line AD. D is given by XY, we don't have those values. Here we have T0, we don't have enough information. So we only have 1 point, and we are required to determine the equation of that straight line. How do we determine the equation of the straight line? We notice some information that BC is parallel to AD, shown by these arrows. Parallel lines have equal gradients, and we have the gradient of BC as 4 over 3. Therefore, the gradient of AD will also be 4 over 3. With that reasoning, we can therefore use the gradient point approach to find the equation of the straight line. And the equation of the straight line AD will be given by 4 over 3x plus 14 over 3. So that is the equation of the straight line AD. 3.4, we are required to calculate, 3.3, we are required to calculate the value of t. How do we find the value of t? T, or the point N, where we find t, 3.3 determine the value of t. T, it's in the point N, which lies on the straight line AD. So all we can do is to substitute these values in the equation of AD. This for the value of x and this for the value of y. And if we simplify that, it gives us t as minus 7 over 2. So the value of t is minus 7 over 2. We simply substituted the point N in the equation of AD because N lies on the straight line AD. 3.4, calculate the length of AN. AN, we already have the value of t, so we have the 2 points. We have the point A with all its coordinates. We have the point N with all its coordinates because t is now minus 7 over 2, and we are required to calculate the length. We can use the distance formula and substitute accordingly to arrive at 5 over 2 units. Therefore, the length of AN will be given by 5 over 2 units, or 2.5 units. And the last question, they want us to determine the coordinates of D if we are given its equation. The equation of D is y equals to 3 over 8x minus 3. So we have the gradient and the y-intercept of this equation DC. So this straight line DC, we have its equation. Now they want us to find the coordinates of D, which are given by x and y. Now you need to note something here. At D, there are two equations. There are two straight lines that intersect, or two straight lines. The straight line AD, which we found the equation of in the previous problem, intersect with the straight line with the equation of DC. So we are given DC, and we have calculated or determined AD, and they intersect at D. So we can simply equate the two equations. This is the equation of AD, which we calculated in the previous problem, and then this is the equation that we are given here. They are equal at that point because they all intersected D. So to simplify this, I simply multiplied both sides by 24, and when you simplify, you get x equals to minus 8. That x equals to minus 8, you can either substitute it in this equation or in the equation that we found for AD to find the value of y, and y is minus 6. Therefore, the coordinates of D are given by minus 8 is to minus 6. What did we do there? We realized that at D, the two straight lines intersect, and we have the equations for both of them. We have the equation for AD, and then we have the equation for CD. Therefore, we equated the equations, solved, and then found the coordinates of D as minus 8 and minus 6. The last question wants us to prove that A, B, C, D is a parallelogram. We already know, because this is given to us, that AD is parallel to BC. So now what is left for us to do is to prove that AB is parallel to CD. So if we can just show that the opposite sides are parallel to each other, we would have proven that ABCD is a parallelogram. We've been given that AD is parallel to BC. So now our only job is to prove that AB is parallel to CD. If we can do that, we would have proven that this is a parallelogram. But let's see. The gradient of CD or DC, since we have the coordinates of D, will be given by 3/8. And the gradient of AB, which we have all the information, is also given by 3/8. Therefore, DC and AB are parallel to each other because they have the same gradient. Remember that parallel lines have the same gradient. So if you show that two lines have the same gradient, you can claim then that the two lines are parallel to each other because they have the same gradient. Then we can conclude then that quadrilateral ABCD is a parallelogram because its opposite sides are parallel to each other. And let's look at one final example. Problem number 4. This is the last one, the last of the problems that we'll be doing in this part of the lesson. Here we are given a quadrilateral, and by just the look of it, we see that TP is parallel to SR, shown by these arrows here. So these two are parallel to each other. We are given the angle theta, which is the inclination of TP, and then the points are also shown there. The first question wants us to write the equation of the straight line PR. Here is the straight line PR. So now to write the equation of this straight line, and it's 1 mark, that means you don't need to do calculations. Look at the coordinate values. The coordinate values will be able to tell you what is happening there. If you look at the coordinate values at C, we have 0 and 5. The coordinate values at R, we have 3 and 5. So the Y value is not changing. And if the Y value is not changing, that tells you that this straight line is perpendicular to the x-axis, is parallel to the x-axis. It is parallel to the x-axis because the Y value is not changing, it's constant. Now, that straight line, it's simply given by y equals to 5. So the equation is simply y equals to 5. It's a horizontal line that is parallel to the x-axis. So it's just a straight line that goes via one value of y all the way. So it's y equals to 5. So horizontal line that goes past y equals to 5. So our equation of the straight line PR is y equals to 5. Let's look at 4.2. Here we are required to calculate the gradient of RS. And to find the gradient of RS, we know that will be the change in y over the change in x. So the gradient of RS will be 2. And 4.2.2, we are required to calculate the size of theta. Theta is the angle of inclination of the straight line TP. We know the relationship between theta and the gradient of TP. We know that the tangent of the angle theta will be given by the gradient of the straight line TP. But we know also that the gradient of TP or PT will be equal to the gradient of RS because they are parallel to each other. Parallel lines have equal gradients. So that relationship gives us theta as 63.43 degrees. Remember, the relationship between the angle of inclination and the gradient of the line of interest It's given by the tangent of the angle of inclination equals to the gradient of that particular straight line. In our case, the relationship between theta and TP is that the tangent of theta equals the gradient of TP. The gradient of TP equals the gradient of PR because the two lines are parallel to each other. Parallel lines have equal gradients. Therefore, we use our understanding of trig. We find 63.43 degrees. That is the angle of inclination. That is the size of theta. And finally, okay, at the third 4.2.3, we are required to calculate the coordinates of D. D is the y-intercept of the straight line RS. In other words, there's the best and the quickest approach to finding the coordinates of D is to find the equation of the straight line RS and then find its y-intercept, and that will give us the coordinates of D. So what we do is find the coordinates, the equation of the straight line RS. We have the gradient of RS, and then we have any other point, so we can simply substitute and find that RS is given by 2x minus 1. So at D, we have the C value, and our C value is minus 1. Remember the C value remember the general equation of the straight line, y equals to mx plus c, where c is the y-intercept, or where the graph touches the y-axis. So our graph touches the y-axis at minus 1 here. It touches at minus 1, and on this straight line, the value of x will always be 0. This is the origin. Just like on this line, the value of y will always be 0. So our x is 0 and y is minus 1. Therefore, the coordinates of D will be 0 is 2 minus 1. 4.3. If it is given that TS is 2 to the square root of 5, TS is 2 to the square root of 5, calculate the value of K. We have been given the length of TS, or the distance of TS, and we are required to find the value of K. So we can use our understanding of the distance formula and substitute what has already been given to us, and then if we simplify this, we should get the value of K. So K is minus 3 or minus 11. So K can be minus 11 in this situation because the biggest y value that we have here is minus, or the smallest y value that we have is minus 7. So for minus 11 to exist, it must be way below this minus 7. Therefore, we can't take minus 11. So the value of K will be minus 3. Right? So that's the reason we get two values, but the minus 11 can't fit because the lowest value that we have, or the smallest value we have, is minus 7. And if you see, K is bigger than minus 7, so it can be minus 11. So our K is minus 3. 4.4, we are told that there is a parallelogram TDNS, where N is in the fourth quadrant somewhere here. We can't even see it. Now we are required to calculate the coordinates of that N. Right, so what we are going to use is the translation. We can use the translation method where we translate points in order to find the coordinates that are missing by just looking at how we moved. Remember, the value of K is minus 3. So how did we move from T to S? So to move from T to S, this was minus 5 to minus 3. So what happened? It would seem that 2 was added to arrive here. So if we add 2, we get minus 3. So positive 2 will get minus 3. And then what happened with Y? Y was minus 3, and then it got to minus 7. That means we subtracted minus 4. So minus 3 minus 4 will be minus 7. So in the same manner, to find the coordinates of N, we are going to use the same translation from D to n. So for the x value, we add 2. For the y value, we subtract -4. Okay, we subtract 4. We added 2 here to arrive here. We subtracted -4 to arrive here. So we are doing the same thing with d. So this is how we are going to find the coordinates of n. We add 2 to the value of x, we subtract 4 to the value of y, and the coordinates of n will be 0 plus 2 minus 1 minus 4, which is 2 is 2 minus 5. Therefore, the coordinates of n will be given by 2 is 2 minus 5. So this is the approach that you'd use to find the coordinates of an unknown point if you are told that the quadrilateral that you are working with is a parallelogram.